Hello everyone. Today we see the new topic, that is the decoder, and the decoder, how it works. Already we learned that mux, demux. It is not a same related to mux, demux, but it is some part, some contents related to mux and demux. It works as an same. In digital electronics, some discrete quantities of information are represented by binary codes, and binary code of n bits is capable of representing some distinct elements as well as some coded information. That is the name we are calling here. We are choosing today's topic, that is the decoder. That decoder means to translate or decode the code information from one format into another. So a digital decoder transforms a set of digital input signals into an equivalent decimal code at its output. And decoder is a combinational circuit that converts binary information from n input lines to maximum some unique output lines. It is a combinational circuit. It accepts a set of inputs that represents a binary number and activates only that output corresponding to the input. Already we told that the figure will be shows the decoder block diagram, that is the n inputs and m is the output, as well as 2 raised to n, that is the unique input combinations for each of these, and one output will be high, that is the active, and other outputs are low. And in decoder have one or more enable pin that are used to control the operation. That enable means some decoders have one or more enable input pins that are used to control the operation of the decoder. For example, in the 3 line to 8 line decoder, if common enable line is connected as an fourth input of each gate, the output particularly written by the ABC input code will be go high only when the enable line is high. There are different types of IC for used for the decoder. That is the 74, that is the LS series 138 decoder, as well as in decoder it is an logic circuit, that is the converts as well as represents n bit binary input code into m number of output lines, such that only one output line is activated for the each one of the possible combination of input. The block diagram represents the decoder input lines, n input lines, and m output lines here. This is the n input lines from the we taken the a0, a1, a2 up to the an, and m as an outputs. Only one input output is high for each input. So tell me the given inputs from the n input side. From that only one output will be high, remaining will be low in the decoder. This is the decoding code, and it receives n inputs, and it activates one and only one of its output. Based on that input with all other outputs, remaining outputs will be deactivated. And n-bit coded information has unused combinations. The decoder may have less outputs. Here is a 2 to 4 line decoder. In 2 to 4 line decoder, the block diagram shows it is an array of 4 AND gates. The two binary inputs here labeled as an A and B are decoded into one of 4 outputs. Hence the description of 2 into 4 binary decoder that each output represents one of the minterms of the two input variables. Each output that is the equal to a minterm is the given details. The block diagram, that is the 2 into 4 decoder shown in figure. A and B are the inputs, two inputs, possible input combinations, that is the 2 into 4, that is the 4, the outputs, that is the 2 raised to 2, that is the 4, and it will be indicated as a D0, D1, D2, D3. And here we taken the truth table. A and B is the inputs, two inputs, hence we require 4 steps, that is 0, 0, 0, 1, 1, 0, 1, 1. And given 0, 0, in that case only one active high pin will be, remaining will be goes low, hence D0 will be gets high. Then A is the 0, B is the 1. In that case second output, that is the D1, will be gets high, remaining will be gets low. In truth table here indicates that. In third number input, that is the A is the 1, B is the 0. In that case D0 will be get low, D1 also low, D2 will be gets high, and D3 will be gets low. And last one, when you give 1, two inputs as an 1, 1, in that case D3 will be active, remaining will be gets low. That is the all about the 2 to 4 line decoder. The 2 to 4 line decoder, using of that truth table, we prepared logical diagram. We prepared first one boolean expression, and after that using of boolean expression we prepared logical diagram. From truth table, the boolean expression D0 will be gets, that is the D0 will be gets, the inputs will be 0, 0, hence we considered A bar, B bar. In D1, here is the B will be gets 1, hence A bar B. In third term, input is the A is the high, B is the 0, hence A, B bar. And last one, that is the two inputs will be active high, hence that is the A, B. Here we get the input as in some output equations. and using of that outputs we drawed here logical diagram. A and B as an inputs, and here is a connected not get, because some of the times we get 0, hence will we get bar, hence we connected not, that is the inverted. The first one D0 in between the AND gate, that is the A bar B bar. Here is the A bar B bar, that is the D0. Next one equation, that is the D1, that is the A bar B, that is the A bar B. Third one is the D2, that is the A B bar A B bar, and D3 is the A B. And this is the logical diagram about the 2 to 4 line decoder. Next, now we going to the 3 to 8 line decoder. Here is the three inputs, that is the A, B, C, because the sentence will be given 3 to 8 line decoder. There is the three inputs. The possible input combinations, that is the three, total 8 combinations, that is the 2 raised to 3, and they are indicated, that is the D0 to D7. Here is the output pins, here is the input pins. From the truth table it is clear that each output is 1 for only specific combination, means from D0 to D7 the one combination will be gets high, remaining will be low from the as per the input sets. We'll see the details. Here is the truth table, the inputs. Here is the 3 to 8, hence we required 8 variables from 0 0 to 1 1 1. This is the inputs. Here is the outputs, and here we take the Boolean equations. The inputs when we given all the A, B, C will be, in that case D0 will be gets high. Means you see that diagonally when you use 0 0 1, in that case second D1 will be gets high, third will be gets high. Means here is the, when you horizontally, then vertically will be gets high. This is also outputs 8 combinations. Here also we taken the 8 combinations. This is logical diagram using of truth table we draw here. That is the A, B, C is the input. Some equations we will get as an inverted, and only taken as an bar. Hence, the first equation we get the A bar, B bar, C bar by using of truth table. Here is the A bar, B bar, C bar. Last equation, all the pins will be gets active high. Hence A, B, C. And this is the logical diagram using of truth table. Here is the how to expand the decoder. There is the lower order decoder for implementing some higher order decoder. That is having some formula, that is the lower order required. That is the M2 upon M1. That is the M2 means there is a number of outputs of higher decoder, higher order decoder, and M1 means number of outputs of lower order decoder. Now you have to use is prepare 3s to 8 decoder from using of 2s to 4 decoder. Here we taken two 2s to 4 decoder, means it having two inputs for first decoder and second 2s to 4 decoder having two inputs. They cascaded with each other. That x and y will be cascaded, means it having only two inputs. But now we have to prepare 3s2, means we required another one pin. We connected here enable pin using of NOT gate, enable high, enable low. That is also cascaded pin, means enable pin and x and y. That is the three inputs. That is the 3s to 8 decoder. and 2:4 decoder having 4 outputs. 2:4 decoder having 4 outputs. Means this 4 means we get the 8 output, that is the 3:8 decoder. Here we mentioned here D0, D1 to D7. That is the output means. Now here given the some examples, implement the following very easy examples. Already we seen in SOP POS forms such type of examples for main-term, next-term purpose. Here is the given multiple output functions using of some suitable decode. Here is the given F in bracket ABC means this is the three A, B, C, three variables, hence that is the three inputs, that is the A, B, C. For the first equation, there is the given summation M 0, 4, 7. Here is the three inputs means obviously here is the comes, that is the 2 raised to 3 means 8 combinations means 8 outputs, that is the from these variables we clear that that is the decoder is 3:8 decoder. Now given values will be connect with output, that is the first one summation M047. Here is the gate 0, that is the 4, and that is the 7. But here is the plus also given don't care conditions 2 and 3. That is the here is the 2 and here is 3. Its total possibilities given for the first equation, that is the 5. Means 5 inputs will be given. That is the 5 output lines will be given. Next equation, that is the summation of 156. Means 3 inputs, that is the 1, 5 and 6. Same for the third one 0, 2, 4, 6. And this is the implementation diagram of decoder. Same here we taken another one example by using suitable decoder. Here is the three inputs means we have to require 8 output lines, that is the 3 to 8 decoder. In that equations values will be put on and we get the different three equations for the F1, F2, F3. Here is another one example. A combinational circuit is defined by the following Boolean expression. Design circuit with decoder and external gate. That is the given equations. X bar, Y bar, Z bar plus XZ. Here we taken Y plus Y complement Y bar as an extra term by using of Boolean law, identity law. And after that multiply that each that term with bracket, that is the X, we get the X, Y, Z and X, Y bar, Z. And then we find out the equation, that is the X bar, Y bar, Z bar. That is the X bar, Y bar, Z bar means, that is the bar means 0, 0, 0. Here will be 0. Next X, Y, Z is 1, 1, 1, that is the 7. Next one 1, 0, 1 means that is the 5, and so we get this equation 0, 5, 7. But we here rearrange that equation. Second one given X, Y, Z bar, X bar, Z. Directly that equation will be given. But here we required Y terms, hence we taken that identity law Y plus Y bar. Multiply that bracket in, we get X bar Y Z and X bar Y bar Z. And after that we find out that equation. Here is the X means 1, Y 1, Z 1 means 1, 1, 0. That is the 6. Here 0, 1, 1, that is the 3. Here is the 0, 0, 1 means 1. We get that equation. And using of this equation we draw here diagram. Now we'll stop here, and next part we see the encoder. I hope you clear that concept decoder. This is the basic concept and very simple concept. We'll stop.